Hello guys, welcome to my YouTube channel. In the chapter called electric charges and electric field, till now we studied what is electric charge, types of electric charges and properties of electric charges so far. And now we know the basic concept of electric charge. And the next important topic in this chapter is called Coulomb's law. So this law, also known as Coulomb's inverse square law. So the name has its own meaning for it, inverse square law, that we are going to study in this video. And the Coulomb's inverse law square law is a law of physics describing the electrostatic interaction between electrically charged particles. So if we have two electrically charged particles, then what is the electrostatic interaction between those two charged particles? That describes the Coulomb's law. Or in simple words, this is the law in which tells us how the electric force would be between two point charges. So what do you mean by point charges? So Coulomb's law tells the force between two point charges, where point charge is nothing but if the dimension of charges. What do you mean by dimension? It may be length, area, whatever it may be. If the dimension of the charges are very small, then such charges are called point charges. So Coulomb's law states that the electrostatic force, what do you mean by electrostatic force? So electrostatic force is an attractive and repulsive force. That is the attractive and repulsive force between particle, and it is caused due to their electric charge, and it is caused due to their electric charge. So now we know what is point charge and what is electrostatic force, and then it is very easy to understand what is Coulomb's law. So Coulomb's law states that the electrostatic force between two stationary point charges, stationary means the point charges are always at rest. If two point charges are at rest, then the electrostatic force between those 2 point charges is directly proportional to their magnitude of charges, that is two values Q1 and Q2, and inversely proportional to the square of their distance between them. And if we have 2 point charges Q1 and Q2 separated at a distance r, then what is the electrostatic force between those two stationary point charge? That describes the Coulomb's law, and it is given that F, that is electrostatic force, is directly proportional to their magnitude, that is magnitude is Q1 and Q2, and inversely proportional to the square of distance between them. So now we know why the law is named Coulomb's inverse square law, because the force is inversely proportional to square of the distance between them. So when we combine these two equations, we will get Q1 Q2 divided by r square, and when we remove this proportionality constant by adding the constant k, we will get the law equation for the law as F is equal to k Q1 Q2 divided by r square. The electrostatic force, the value F, will be attractive or repulsive depending upon whether the charges are like charges or unlike charges. So in this diagram we have two two charges, that is first one is two positive charges and second one is one positive and negative charges. So what happens in the case of two like charges, that is if we have two positive charges, then there will be force of repulsion, because equal charges always repulse each other, and if we have two opposite charges, then the force of electrostatic force between those 2 points charge will be force of attraction. And because we are considering the mod here, the equation always will be in positive. Even though the charges is positive or minus, we are considering modulus here, so the final value will be always in positive. So we have to consider the charge value in positive, whether it is in negative or positive. Since we are considering the modulus, the final value will be always in positive. So in equation, the proportionality constant K is known as Coulomb's constant. And the value of Coulomb's constant is K is equal to 1 divided by 4 pi epsilon naught, where epsilon naught is the permittivity of free space. And substituting the values, we will get the value of K as 9 into 10 to the power 9 Newton meter square per Coulomb square. So this is the value of K. So this is the value of K only when the charges are situated in free space. Okay. When we substitute epsilon naught, permittivity of free space, then only we get the answer of K as 9 into 10 to the power 9 Newton meter square per second square. So this is the value of K only when the charges are situated in free space. So this is the equation to calculate the electrostatic force between two stationary point charges. So suppose if we are considering Coulomb's law in vector form, that is, consider two like charges Q1 and Q2 separated by a distance r in vacuum. So obviously if you consider two positive charges, obviously the force of electrostatic force will be repel each other. So consider Q1 here and Q2 separated at the distance r, then force of repulsion on Q1 due to Q2 will be F12, and force of repulsion on Q2 due to Q1 will be F21. So where F12 is the force on Q1 due to Q2 and F21 is the force on Q2 due to Q1. Then suppose R12 be the unit vector pointing from Q1 to Q2 and R21 be the unit vector pointing from Q2 to Q1. Then the equation of force becomes F12 is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by unit vector we need to consider, that is R square, unit vector as R21. So this is the force of repulsion on Q1 due to Q2. Similarly, force of repulsion on Q2 due to Q1 is 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. Unit vector is R12. So these two are the equation of force, that is general equation of Coulomb's law when we consider it is in vector form. So these about equation express Coulomb's law in vector form. So this is all about the Coulomb's law.